A black hole is usually a place in space where no light exists, making it all but impossible to capture on film. Despite this, a team of astrophysicists have managed to photograph a black hole in our galaxy, the Milky Way, for the first time. Palab Ghosh reports.
What exactly is inside a black hole? This mystery question has kept many physicists and researchers on the edge for years. And this is what we will discuss in this video. While we have not gotten any suitable answers for years, Michio Kaku might just have saved the world with his recent discovery. What is inside a black hole? The recent achievement in getting the first photograph of a black hole was a landmark milestone in astrophysics, ending a century-long quest that began in 1916. Black holes, with their inexplicable gravitational pull, test our understanding of the universe. These mysterious phenomena appear in a range of sizes, from stellar to supermassive, and their study has become a theoretical playground for physicists. Despite some answers coming to light, much about black holes remains unknown, notably what happens within them, which is why we are here. To understand this better, there is a need to look deeply into what a black hole is. The fascinating world of black holes. Black holes are among the most strange and exciting objects in space. It is simply a big, dead star whose gravity is so strong that even light cannot escape, hence the name. Because it cannot be seen, NASA scientists concentrated on the tiny core of the galaxy M87, a super-enormous cosmic engine 50 million light-years away from Earth. Astronomers later discovered that the core of the research was a ferocious, swirling maelstrom of superhot hydrogen gas spinning at 1.2 million miles per hour. To keep this spinning disk of gas from violently separating in all directions, it required a massive mass concentrated at its center, weighing as much to 2 to 3 billion suns. An item of that astounding mass would be so big that light would be unable to escape. As a result, we have a black hole. However, advancements in technology, such as gravitational wave detectors and radio telescopes, have enabled scientists to examine their impact on space. Event Horizon Telescope. The Event Horizon Telescope obtained a groundbreaking image of a black hole, revealing a brilliant ring of hot gas spinning around the event horizon, providing insights into the perplexing nature of these cosmic creatures. However, recent theories, such as loop quantum gravity, question conventional wisdom, predicting alternate results such as the generation of Planck stars or gravastars. As an intriguing substitute for black holes, gravastars offer a way around the singularity issue without depending on theoretically questionable quantum gravity. Rather than being a singularity, they are teeming with dark energy, a material component that is accelerating the expansion of the universe. Similar to a black hole's event horizon, stuff that falls upon a gravastar is confined on its surface by dark energy. Well, we will go into this as we delve deeper into the video. The first discovery of black holes. Albert Einstein predicted the existence of black holes in 1916 with his general theory of relativity, but it was not until much later that John Wheeler, an American astronomer, created the term black hole in 1967. For decades, black holes were only recognized as theoretical things, which were suspected to exist but never seen. The first black hole to be identified was Cygnus X1, which was located in the Milky Way's constellation of Cygnus, the Swan. According to NASA, astronomers discovered the first hints of a black hole in 1964, when a sounding rocket identified celestial X-ray sources. Astronomers established in 1971 that the X-rays came from a bright blue star orbiting a weird dark object. It was proposed that the discovered X-rays were caused by stellar material being taken away from the bright star and gobbled up by a dark object, an all-consuming black hole. In 2021, astronomers presented a fresh image of M87's huge black hole, revealing how the colossal object appears in polarized light. Polarized light waves have a different orientation and brightness than unpolarized light, so the new image depicts the black hole in greater detail. Polarization is a characteristic of magnetic fields, and the image clearly shows that the black hole's ring is magnetized. They discovered that a black hole has 3 layers, not the one huge gaping hole of nothingness that many people think it is. To reach the nothingness portion of a black hole, you must first pass through the first 2 layers. The 3 layers. The 3 layers are categorized as a singularity and the inner and outer event horizons. The event horizon is the first layer. It is the area surrounding a black hole's mouth, beyond which light cannot escape. A particle cannot escape the event horizon once it has crossed it. Over the entire event horizon, gravity remains constant. Although black holes cannot be thoroughly studied using conventional scientific methods, some intriguing theories on their formation and behavior have been put up by researchers. The second layer encircling a black hole is known as the photon sphere. This sphere has light circling it. When light enters this region, it is imprisoned by the black hole's gravitational force. Finally, there is the singularity, where everything that enters the black hole is infinitely squeezed, defying the laws of physics as we know it. Singularity is a point in space-time where the laws of physics no longer apply. The density is infinite, and the laws of physics cease to exist. Each black hole studied will be unique, despite following the same three-layer concept. This is because investigating black holes is incredibly tough because each one behaves differently, and typical scientific methods don't apply due to the breakdown of physics principles inside them. Scientists can only indirectly observe black holes by studying the radiation they release and the surrounding objects. When something enters a black hole's event horizon, it's like being sucked into a massive cosmic vacuum. Anything that goes in is crushed into a tiny point known as a singularity. So, spending billions of dollars on a probe to peek inside a black hole would be pointless because the instant it comes close, it is smashed into nothingness. As a result, scientists must examine black holes from a distance, as if they were staring at a picture rather than entering them. Even though black holes exist in 3 dimensions, scientists can only examine them in 2 dimensions. This is due to the difficulty of exploring them up close. It is even more difficult because each black hole is unique, like cosmic snowflakes, and when they try to explain what's going on inside by applying standard physics concepts, it just doesn't work. But don't believe scientists are just sitting there scratching their brains. They've come up with numerous theories and explanations for black holes, and with each new concept, things become increasingly exciting. Theories. One of the most intriguing theories regarding black holes is that collapsed stars form them. When a star runs out of fuel, it loses its ability to resist gravity. As a result, it collapses within itself, shrinking and getting denser. If the star is extremely massive, the collapse can continue until it reaches a singularity, which is similar to a super small point with infinite density. Roy Kerr, a mathematician, proposed another interesting theory. He described spinning black holes in terms of Einstein's equations. Instead of collapsing into a point, Kerr advocated a spinning disk, known as an ergosphere. Kerr's answer also predicted something extraordinary: wormholes. These are hypothetical tunnels that could link different sections of the cosmos or perhaps alternate universes. Although wormholes are fragile and will most likely collapse rapidly, the concept of them as gateways to enter other areas of the universe or different timelines is very intriguing. But might we use wormholes to travel through space and time? Probably not, at least not right now. Even if we could stabilize a wormhole, traveling faster than light, as required, would contradict Einstein's theory of relativity. The Kerr wormhole, named for mathematician Roy Kerr, is a hypothetical tube through space-time that could connect distant places, such as worlds or times. While intergalactic or time travel sounds exciting, it is problematic due to stability problems and the necessity for a unified theory of everything. Michio Kaku on black hole. Michio Kaku's research, particularly in superstring theory, seeks to reconcile gravity with quantum mechanics. This hypothesis proposes more dimensions beyond the 4 humans perceive, which could explain phenomena such as black holes and wormholes. Superstring theory, while difficult, has the potential to transform our understanding of the cosmos, but its solutions are dependent on beginning conditions, including those that existed before the Big Bang. The mathematics of superstring theory is extremely complex, resulting in new areas of mathematics. However, the problem of a quantum black hole remains unsolved. A few months back, researchers discovered that string theory could address the quantum black hole problem, although in 2 dimensions instead of 10. While scientists believe the problem will be solved in due course, it is yet too early to plan intergalactic or time-traveling trips involving black holes. Michio Kaku emphasizes the significance of setting beginning conditions in string theory, analogous to Newton's laws. One strategy is to find the initial circumstances at the time of the Big Bang, and then use string theory to describe the universe's history from there. Alternatively, demanding that string theory chose its beginning conditions is a more ambitious but unlikely option. Despite the hurdles, progress has been made in narrowing down the options for understanding the universe's intricacies. And that is it. What are your thoughts? Let us know what you think below in the comments section. And also click on that subscribe button now, and do not hesitate to hit the notification bell.